Here's a question. Take an entire song's lyrics, all of them, stored as one long string of text. How would you find the words that appear most often? You could try to eyeball it, but a real program has to count every single word and then rank them. This is exactly where dictionaries shine. Across this video and the next, we'll build a small program that does this, split into 3 cooperating functions. Today we build the first and the most important one, the function that does the counting. First, a quick recap of the tool we're using. A list is an ordered sequence. There's an element at index 0, an element at index 1, an element at index 2, and so on. Those indices are fixed. They're integers, they run in order, and the index 0 has to exist before anything above it can. A dictionary also has something index-like, but we call the labels keys, and the keys are custom. Think of it as being free to rename and rearrange the indices however you like. There's no order you can index by because keys aren't positions. There's one restriction: keys must be immutable, or more precisely, hashable. Beyond that, the value you store under a key can be any type at all, exactly as with a list. Before writing any code, picture the finished product. The song is one long string. What we ultimately want handed back looks like this: a list where the first entry says the word I occurs 18 times, the next says we occur 17 times, and the next says the words ain't, ever, getting, and the older each occurs 16 times. That's 4 different words tied at the same count. Notice that ain't has lost its apostrophe because the lyrics were cleaned up first. The entries march downward in frequency. From the most common word at the top down to a cutoff, we choose, say, every word that appears at least 6 times. That's the goal. Now let's work backward to reach it. That's a big task, and you won't write it all in one go. Instead, break it into 3 smaller pieces. 1. Build a frequency dictionary. Given a string of words, produce a dictionary that maps each word to how often it occurs. 2. Find the word that occurs most often. With the frequency dictionary in hand, you look at its values, find the largest, then see which keys carry that value. 3. Find every word that occurs at least some number of times. Each piece gets easy once the data is represented as a dictionary. In this video, we build piece 1. The next video builds pieces 2 and 3. To develop and test the counting function, we need a song. This one is short, deliberately repetitive, and it fits on a single line. Its punctuation, the commas and exclamation marks, was stripped out beforehand, because straight punctuation will corrupt the counts. A frequency dictionary is a fancy name for a simple idea. It maps each word to its count inside the string. The real payoff is that it represents that raw run of words in a far more useful shape. Our task is to turn this line of text into a dictionary of word counts. Let's write the function that does it. Here's the function, called generateWordDict. It takes the song string and returns a dictionary. Walk through it top to bottom. First, convert every letter to lowercase. That's real work here, since this test song is written entirely in capitals, and we want the capital and the lowercase versions of a word counted as the same word. Next, use split, called with nothing inside the parentheses. Given no arguments, split breaks the string on white space, turning it into a list of words, which is far easier to work with than one long string. Then create an empty dictionary. Now loop over the words. There are only 2 cases. Either the word is already in the dictionary, which we check with the in keyword, and then we increase its count by 1. Or the word is new, and then we add it with a count of 1. Finally, return the dictionary, which maps strings to integers. Now trace it by hand, the way Python tutor would. After lowercasing and splitting, we have a list of 10 words. Ra, ra, rom, ma, ro, ma, ma. The dictionary starts empty. First word, ra. Is ra already in the dictionary? No, it's empty, so we take the else branch and add ra with a count of 1. Second word, ra again. This time, ra is already there, so we take the if branch and bump its count to 2. That's the whole pattern. New words take the else and start at 1. Repeats take the if and go up by 1. Watch the 3 kinds of moment. That very first ra is a first time insert. Nothing was there, so the else branch created the entry. The second ra is the first repeat. The word is found, so the if branch adds 1. Now keep going. Next comes brand new, added at 1. Then again, up to 2. Then a third up to 3. Now rum, new, added at 1. Then ma, new at 1. Then ro, new at 1. 2 words are left, both ma. And this is the later repeat to watch. Ma was inserted once, said quietly while other words went by, then gets bumped twice at the very end, to 2 and then to 3. And we're done. Every word landed in exactly one of the 2 branches. New words were inserted, repeats were incremented, and after 10 words, the dictionary holds 5 keys with their counts. The order the keys appear in, ra, rum, ma, ro, is simply the order each word was first seen. That's not a ranking, and it's not something to rely on. Here's the result. The function returns for our test song. Read it off. Ra2, R3, Rom1, Ma3, Ro1. That's a compact, faithful summary of the whole song. We've turned an unwieldy string into a structure we can actually reason about. And that was the entire point of piece 1. With the counts in hand, the hard part is nearly over. In the next video, we write piece 2, find frequent word, which reads these counts and picks out the winner. And the piece 3 occurs often, which lists every word above a chosen threshold. The frequency dictionary we just built is what makes both of them easy. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.